Our essential question today is, how do I write conditional statements We all use conditional statements in our daily lives. For example, if you clean your room, then you can go to the movies. If you play nice with your brother, then you can have dessert. If you go to work, then you will earn a paycheck. These if-then statements are what we call in mathematics a conditional statement. The outcome, the then, depends on what you did to start with, or the input, the if. So in mathematics, a conditional statement is a statement that can be written in if, then form. Symbolically, we use P to represent the if, Q to represent the then, and we draw an arrow pointing from P to Q. These are both lowercase letters. We read this if P, then Q. The hypothesis are the words immediately following the word if, and the conclusion, conclude, would help if I could spell, immediately follows the word then. Okay, hypothesis is a word you should know from science, and conclusion is a word that you know both from science and from English class. Alrighty, some examples here. Identify the hypothesis and the conclusion of the following statements. Now, hypothesis is our P, and conclusion is our Q. So hypothesis is P, conclusion is Q. If you live in Nashville, that's our hypothesis. So you live in Nashville. We don't include the word if, okay? Then you live in Tennessee. So you live in Tennessee is our conclusion. All right, let's look at number 2. If the sum of the measures of two angles is 90 degrees, so if, that's our hypothesis, P, the sum of the measures of two angles is 90 degrees, then they are complementary angles. This is our conclusion. They are complementary angles. There's going to be a lot of writing in this unit, a lot of sentences. That's something you've just got to get used to. Again, when we identify the hypothesis and the conclusion, we don't include the words if or then. So if a quadrilateral is a square, that's our hypothesis. Quadrilateral, by the way, means a four-sided shape. Then it has 4 right angles. That's our conclusion. Instead of underlining, some people like to use highlighters and highlight their hypothesis each and every time and then underline their conclusion. Whatever you need to do, I like color, but whatever you need to do in order to make this stand out for you, that's important. Write the following statements in if-then form. Now, when we do this, we want our statement to be true. Okay, so an obtuse angle has a measure greater than 90 degrees. So Let's do if an angle is obtuse, there'll be my hypothesis, then it has a measure greater than 90 degrees. That will be my conclusion. So if an angle is obtuse, you have to have a comma after your hypothesis, then its measure is greater than 90 degrees. Now, the statement has to be true when you write it in the if-then form. You have to have a comma after your hypothesis. Okay, and it also needs to make sense grammatically, or you need to try to write a good, solid English sentence. All right, number 5. All numbers divisible by 4 are also divisible by 2. So if we are divisible by 4, then we are also divisible by 2. That'll be a true statement. So if a number is divisible by 4, that means we can divide it by 4, and we don't get a remainder, then it is also divisible by 2. Okay, remember the comma after the hypothesis and the period at the end of your sentence, please. Number 6, states on the East Coast border the Atlantic Ocean. Okay, so if we're on the East Coast, hypothesis, then we will border the Atlantic Ocean. Border just means we touch. So if a state is on the East Coast, comma, then it will border the Atlantic Ocean. Okay, number 7. Valentine's Day is in February. So I could say if it's Valentine's Day, then it's February. That would be true. If I say if it's February, then it's Valentine's Day, that's not true because there are, 27 or 28 other days in February that aren't Valentine's Day. So Valentine's Day is going to need to be my hypothesis this time, and February is going to need to be my conclusion. So if it is Valentine's Day, then it is February. Okay, prime numbers have only 2 factors, 1 and itself. Okay, so a prime number, that's like 2 because you can only get 2 by 2 times 1. 3 because that's only 3 times 1. 5 because that's only 5 times 1. So if a number is prime, then it only has 2 factors, 1 and itself. Hypothesis, conclusion. If a number is prime, then it only has 2 factors, 1 and itself. Hey, if you hit any of these and you don't have the background knowledge to write the if-then statement, you need to look up the words you don't know. All right, negation. A negation of a statement changes a true statement to a false statement. So I won the lottery. I did not win the lottery. That would be a false statement changed to a true one because I did not win the lottery. I earned an A in math. I did not earn an A in math. I earned an A in math being my true statement. I did not earn an A in math being my negation or false statement. We usually add that word not. For a symbol, we use the tilde. That's what it's called in both Spanish and English. This symbol is used for several different things in geometry, and you know what the meaning is based on the context. So you're going to use context clues as you move throughout geometry to know what that symbol means. So some examples. Write the negation of the following statement. There are 7 days in a week. How about there are not 7 days in a week? Or there aren't. Aren't sounds a little better as a contraction. There aren't 7 days in a week. This one went from a true statement to a false statement. Okay. March has 30 days. That happens to be false. March does not have 30 days would be my negation. It has 31, by the way. That turned a false statement into a true one. Again, as you're doing this, watch your grammar, watch your English. Halloween is on October 31st. That happens to be true. Halloween is not on October 31st would be our negation. And that one happens to be false. So we can take a true statement and make it false. We can take a false statement and make it true. All right, the inverse of a statement is formed by I'm sorry, I had someone walk in the classroom and I got distracted there for a second, so I paused it. The inverse is formed by negating the hypothesis and the conclusion. Now remember, for our conditional statement, our symbolic form was P, then Q. So if we're going to negate it, we're going to say not P, then not Q. The converse is formed by taking your conditional statement and switching the hypothesis and the conclusion. So instead of P then Q, I'm going to say Q then P. The contrapositive is formed by switching and negating the hypothesis and the conclusion. So not Q, then not P. You do need to memorize these symbolic forms for the conditional, the inverse, the converse, and the contrapositive. I recommend making yourself some flashcards. All right, write the inverse, converse, and contrapositive of the following conditional statements. If it is Saturday, that's my hypothesis, P. Then there is no school, that's my conclusion, Q. Now the inverse is the negation. So I'm going to write not P, then not Q. So if it is not Saturday, oops, capitalize Saturday, comma, okay, then there is school. I'm turning the no school into a positive. Then there is school. Okay. The converse is formed when I switch the hypothesis and the conclusion. So Q, then P. So let's see here. If there is no school, if there is no school, comma, then it is Saturday. And the contrapositive is formed by both negating and switching. So not Q, then not P. So let's see. If there is school, then it is not Saturday. Takes practice to do these. It definitely takes practice. Let's take it look at the next one rather. If the product of two numbers is odd, this is my hypothesis. Okay, remember product means to multiply. So 3 times 5 is 15, for example. Then both numbers must be odd. That is my conclusion. Alrighty. Inverse means to negate the hypothesis and conclusion. So not P, therefore not Q. So my hypothesis, the product of two numbers is odd. So to negate that, the product of two numbers is not odd. If the product of two numbers is not odd, okay, my conclusion has to be negated. Both numbers must be odd. So to negate that, both numbers must not be odd. Then both numbers must not be odd. All right, next up, my converse. I'm going to switch. So conclusion, then hypothesis. If Q, then P. So if two numbers are odd, then the product of the two numbers is odd. I think I should have left more space for all these words in my big handwriting. Okay, the contrapositive switches and negates. So not Q, then not P. Okay, so I can look right here at the converse and simply negate the converse to write my contrapositive. Because the converse is Q, then P, the contrapositive is not Q, not P. So if two numbers are not odd, comma, then the product of the two numbers is not odd. Getting close. If the temperature is 20 degrees Fahrenheit, so that is my hypothesis, then it is below freezing. That is my conclusion. Okay, so my inverse, I'm going to negate this, not P, then not Q. So if the temperature is not 20 degrees, Fahrenheit, then it is not below freezing. The converse switches. So if Q, then P. If it is below freezing, then the temperature is 20 degrees Fahrenheit. The contrapositive both switches and negates. So not Q, then not P. Okay, so I like to look at my converse and negate my converse. If it is not below freezing, then the temperature is not (20 degrees Fahrenheit). Okay, so I'd like you to take a minute and write some guiding questions for the examples and write a summary of this lesson. Be sure you include how to write the inverse, converse, and contrapositive when you're given a conditional, and the symbolic form for the inverse, converse, and contrapositive.